You ever watch a drone just hang in the air perfectly still, even when the wind is blowing? Or see a camera lens snap into focus in the blink of an eye? It almost feels like magic, right? But it's not. It's this brilliant piece of engineering, an invisible engine that's pretty much running our entire modern world. And today, we're going to pop the hood and see how it works.
So what's the secret sauce? Well, it's this amazing mix of pure, raw power and incredibly intelligent control. We're about to pull back the curtain on this hidden engine that lets machines do more than just move. It lets them truly master motion.
Okay, so let's imagine we're building a robot. The very first thing we're going to need is a motor, something to make it go. And for decades, the go-to was a pretty simple, classic design. But as you're about to see, that classic design came with some serious baggage. Yeah, the old way was surprisingly physical. I mean, you had these little graphite brushes that were literally scraping against a spinning part to get the power where it needed to go. And you can guess the problems, right? Friction, which means wasted energy, parts that physically wear down and have to be replaced. Oh, and all that scraping created sparks and a ton of electronic noise that could mess with other circuits. It was a design that just couldn't keep up.
So, engineers knew they needed a better way. They had to ditch the friction, ditch the wear and tear, and for sure, ditch the sparks. The solution was kind of brilliant in its simplicity. Just get rid of the brushes altogether. And that led to a totally revolutionary upgrade, the brushless DC motor. Now, this didn't happen overnight. For most of the 20th century, those brushed motors were pretty much the only game in town. The real game changer came in the 1960s with the rise of solid-state electronics. All of a sudden, you could replace that clunky, physical switch with a smart, tiny electronic controller. And that changed everything.
And I mean, just look at the difference. It's night and day. On one side, you've got the old way, with all its problems. On the other, the brushless motor is just a clear winner across the board. It's way more efficient, way more reliable, and it's safer because, no sparks. So great, we've got a much better engine. But that's only half the story. Because here's the thing, a powerful, efficient motor is really just raw power. If you just hook it up to a battery, it's going to spin like crazy, totally out of control. To get that pinpoint precision we were talking about, the motor needs a brain. It needs a control system.
And control systems basically come in two flavors. First, there's open loop. This is kind of like shouting a command into a room and just hoping for the best. It sends the order, but it has no idea if the motor actually did it right. It's like trying to touch your nose with your eyes closed. You'll get close maybe, but you won't be precise. But a closed-loop system? That's like opening your eyes. It sends the command, and then it uses a sensor to check the result and instantly correct for any little error.
So you take that awesome brushless motor, and you pair it with that smart closed-loop brain, and what you get is a servo mechanism. It's such a powerful concept. The name is actually super telling. It comes from the Latin word servus, which means slave. Why? Because the whole system is designed to slavishly follow a command, constantly correcting itself until it hits its target perfectly.
So let's dive into the heart of that servo brain. It's all about this constant, non-stop process that lets a machine know exactly where it is, where it's supposed to be, and how to close that gap in an instant.
This quote just nails it. The entire system is completely obsessed with one thing, finding the error. That's the tiny gap between the goal and reality, and getting rid of it. It's just this relentless cycle of check, correct, check, correct.
So check this out. Here's how that cycle works in real time. First, the controller sends a command, move to 90 degrees. The motor takes action. But almost at the same time, a sensor gives feedback, saying, hey, we're actually at 88 degrees. The controller instantly sees that 2-degree error and issues a correction, telling the motor to nudge just a little bit more. And this whole loop? It's not happening once a second. We're talking hundreds, maybe even thousands of times every single second. The result is just incredibly smooth, perfect motion.
Okay, so we've got a better motor, we've got a brilliant brain controlling it. Big deal, right? Well, it's a huge deal. Because once you know what you're looking for, you start to realize this invisible engine is running the world all around us, often in places you'd never expect. Just think about your own house. You know the little head in the computer hard drive that has to position itself with insane accuracy to read your files? That's a servo mechanism. The autofocus on your camera lens? Yep, that's a servo. The paper feeding perfectly through your printer, the quiet hum of a modern washing machine? It's all powered by this amazing tech. And then you look at the industrial world, and whoa, it is the absolute backbone of modern automation. Every single robot arm on an assembly line, every precise cut made by a CNC machine, every tiny computer chip placed perfectly on a circuit board, all of it depends on the flawless, relentless precision of servo mechanisms.
And the list just keeps going.
This is the tech that lets a drone hover. It's what gives an electric car that instant, thrilling acceleration. It controls the flight surfaces on a modern jet. It's even pushed our hobbies, things like high-speed RC cars and battle robots, to absolutely mind-blowing levels.
And when I say mind-blowing, I mean it. Get this. A high-end RC car using one of these brushless servo motors can hit speeds over 160 kilometers per hour. That's almost 100 miles an hour. That is just a staggering amount of controlled power in a package that fits in your hands, and it's all thanks to this tech.
So, there you have it. From the tiny lens in your phone to the giant robots that build our cars, the servo mechanism is the invisible engine of our time. It's the technology that has allowed us to completely master motion. Which, of course, leaves us with one last big question. Now that we've taught machines how to move perfectly, what are we going to teach them to do next?
Please like, share, and subscribe for appreciation and such more learning friends.